Continuing on with this endochondral ossification, we're going to now look at Handout 6F. And Handout 6F is going to show us in more detail this epiphyseal plate. So if I open up our handout, I've got this same picture essentially that we had in the last handout. Okay, so here's our last handout, endochondral ossification, handout 6E. In handout 6F, I'm just taking and we're looking at the epiphysis, the end of a bone. And so I'm just expanding this and we're talking about the epiphysis. And so this epiphysis has a strip of cartilage that is in between, remember, that primary ossification center and the secondary ossification center. We've got this epiphyseal plate. Now, the epiphyseal plate is, remember, commonly called our growth plate. And the growth plate is made up of several zones. And these zones contain cartilage. So this is all cartilage. From the epiphysis side to the diaphysis side, we have this cartilage. And if we look at this, at the epiphyseal side, the top or bottom, however you want to look at it, depends on what bone we're looking at. But at the epiphysis side, this area of cartilage is called the zone of resting. And this cartilage is just really not doing much. It's just kind of sitting there. So it just says cartilage attaches to the epiphysis and there's no growth involved. Well, then a little bit deeper towards the diaphysis, we've got this other strip of cartilage called the zone of proliferation. Well, proliferation means growth. So it says new cartilage is being produced in this area, and it is forming chondrocytes. Those are cartilage cells that are dividing and making stacks of cells. So we have mitosis going on. We're creating new cartilage chondrocyte cells, and these chondrocytes are multiplying in this zone of proliferation. Now, as these cells are being made in the zone of proliferation, they're getting pushed into this third zone called the zone of hypertrophy. Well, remember what I told you in a previous chapter. Hypertrophy just means growth. So these cells are enlarging, they're getting bigger. So these cells are getting pushed down into the zone of hypertrophy where they're enlarging and getting bigger. Now, these cells are then further pushed towards the diaphysis, into the zone of calcification. Now, this zone of calcification is going to be where our cartilage cells, the chondrocytes, are going to start getting filled with calcium. They're going to start to calcify, and these chondrocytes die and then are replaced by osteocytes, by the bone cells. And so by the time we get down to the diaphysis here, the chondrocytes have completely been calcified and replaced by ossified bone. So these cells down here at the bottom towards the diaphysis are now bone cells that make up the diaphysis. Now, this is how we grow. So these chondrocytes in the zone of proliferation and the zone of hypertrophy are causing this bone to grow in length. So we are growing this bone as these chondrocytes develop and then get calcified and turn into bone cells. Now, over here on the right, I've got some information that talks about how growth occurs in bone. So it says cartilage grows in length at the epiphyseal plates. Well, we already knew that. And it says, number 2, hormones are going to be in control of the growth of cartilage. There are really 3 types of hormones that play a role in the growth of the epiphyseal plate. The first one is human growth hormone. Human growth hormone actually grows not just bone, but pretty much tells all tissues of your body to grow. So it's playing an important role in bone growth. The male sex hormone testosterone is playing a huge role in bone growth. And then our thyroid hormones are playing a role in bone growth. Now, don't worry about this. It says see handout 14. We'll get to that a little bit later. But a third factor is our female hormone. The female hormone estrogen is also going to play a role in bone growth because estrogen is going to stop the epiphyseal plate. So our epiphyseal plates are going to fuse into what's called epiphyseal lines. And these epiphyseal lines have no cartilage in them anymore. And so it's estrogen that causes this. So this is a little bit off. For girls, this is kind of a boy statistic. For girls, I don't know, it's around age 14 to maybe age 16 years old. Our estrogen builds up, and the estrogen tells this cartilage to die. When the cartilage dies, this epiphyseal plate becomes an epiphyseal line. It's because of estrogen. Now, something to think about with this, when you think about boys and girls growing, a couple of questions come to mind. If you think about it, girls always stop growing before boys. All right. And boys usually, by the time you're in high school, boys outgrow girls and get taller. Well, why is that? It's because of our sex hormones. Testosterone is the male hormone, and it tells our epiphyseal plates to grow. So boys, when they're churning out testosterone, they're going to be growing. Now, you ladies also make testosterone, okay? So your ovaries make estrogen, but your adrenal glands make testosterone. And so girls also produce some testosterone, just not as much as boys. And so the testosterone in girls tells your bones to grow as well, along with human growth hormone and thyroid hormone. However, when girls hit puberty, their ovaries start churning out lots of estrogen. And so by the time a girl reaches 15, 16 years old, she has built up enough estrogen in her body to turn off the growth of the cartilage in the epiphyseal plates, and her epiphyseal plates fuse and become epiphyseal lines. And those epiphyseal lines do not have cartilage for growth anymore. So that's why you girls have stopped growing, probably when you were in high school. My daughter is going to be 20 this year, but she hasn't grown in 5 years at least. And so, it's kind of funny because, clothes that she bought when she was 15 years old still fit her when she's 20 because she's not growing anymore. And that's because of estrogen. Now, see, boys are a little bit different because we're making a lot more testosterone, so we're growing more. We've got all this growth occurring more, so we're going to start growing taller. But unlike girls, where you produce some testosterone in your adrenal glands, and you produce estrogen in your ovaries, boys do not have a gland where we make estrogen. We do not have a gland that makes estrogen. So what happens is we continue to grow into our 20s. And what ends up happening is we build up enough testosterone in our body that some of this testosterone is converted into estrogen. And when we convert that testosterone into estrogen, then our epiphyseal plates fuse and become epiphyseal lines. But this takes time to build up. So we don't build up enough estrogen to stop the epiphyseal plates until our 20s. And so some of you young men may, if you're in your early 20s, you may still be growing a little bit. And that's going to stop soon. But you have to build up enough estrogen to actually stop growing. And so this explains why girls stop growing earlier than boys and why boys tend to grow taller than girls. It has to do with our testosterone and estrogen levels. So this kind of takes care of our epiphyseal plates. All right, so some interesting things about that, epiphyseal plates can be affected by these hormones. And that's also why, we have this nature versus nurture. If you don't have enough hormone, along with the production of calcium and vitamin A, vitamin C to grow your bones, you may be shorter than you should be, or you may grow taller. It all depends on these other factors. And that's kind of what I want to get into right now. Let's switch gears, and I'm going to go back to our PowerPoint just for a few minutes because we've got a few things to take care of that still deal with bone growth. First of all, remember, bone tissue can only grow in thickness. And so this is just a diagram that shows that bone tissue, I should say, only grows in thickness. Now, getting thicker is called oppositional growth. And you don't have to know the details of this, but you need to realize that sheets of bone can be laid down, making that bone thicker. Right? We call this oppositional growth. And so this bone, you can see right here, it's getting thicker. And this thicker bone, let me see if I can get a different color here of my pointer. This is getting thicker. All right, that's oppositional growth or growth in thickness. Cartilage grows our bones in length. Bone itself can only grow in thickness. Now, just some other things that are affecting bone growth. Nutrition. We need vitamin D and vitamin C to grow healthy bones. So vitamin D is necessary for calcium absorption to make that mineral matrix of our bones. So if you don't have enough calcium, you can't build strong bones because you're not making your minerals. Vitamin D plays a role in that. There's a disease called rickets. If you don't have enough calcium in your diet, you get this disease called rickets. Vitamin C, another important vitamin, is necessary to make that collagen that builds the other part of the matrix of your skeleton. So remember, collagen is going to make your bones very flexible and durable, whereas the calcium minerals make your bones very hard and strong. And so if we don't have enough vitamin C, that results in this disease called scurvy. And you think of scurvy, it was one of those historic diseases that seamen on a ship in the 1800s would suffer from because they weren't eating fresh vegetables or fruits that had vitamin C. And so once this was discovered and we knew how to treat scurvy, they started packing the ships with limes. And this is why the British Navy is still to this day called limeys, because once we figured out that vitamin C is what prevented scurvy, they started packing their ships with barrels of limes, and they would make their sailors eat the limes, and that would prevent any scurvy. And then, of course, our hormones, right? So I just mentioned that human growth hormone is going to affect bone growth. Our thyroid hormones are going to be responsible for the metabolism of the bones and causing bone growth. And then our sex hormones, estrogen and testosterone. Testosterone is going to cause bones to grow, and estrogen is going to cause bones to stop growing. However, it's also important to understand that estrogen is responsible for maintaining bone health. So your bone cells need estrogen to make the proper minerals and collagen. And so bone health is related to estrogen. Now, some hormonal abnormalities come to mind when we think about this. And so let's think about human growth hormone. Human growth hormone is a hormone that causes growth in all your tissues. But if you oversecrete it, you get taller and taller. That's a disorder called giantism. So you get a person of really large stature because they're oversecreting human growth hormone. If we undersecrete human growth hormone, we get a condition called dwarfism, a person that's shorter and smaller than normal, and that's because they're not making enough human growth hormone. And these hormones affect a lot of our long bones, the bones with the diaphysis and the epiphyses. So your bones of the appendicular skeleton, your humerus, your ulna, your radius, your femur, the tibia. And so that affects how tall we get. Now, our bone cells at the epiphyses have estrogen receptors. These estrogen receptors are going to accept estrogen, and that estrogen then turns off bone growth. Well, if you have a genetic mutation where you don't have these estrogen receptor proteins, then you don't get a signal from the estrogen to stop the growth. So you continue to grow, and people can get taller and taller and taller. You may be familiar with there's a population of people in Africa that are over 7 feet tall, and that's a genetic thing that they pass on to their children, and it's due to these estrogen receptors. Estrogen is responsible for closure of the growth plate, and if you lack these receptors, then you just keep growing. All right. So these are just some hormone abnormalities. All right. So this kind of wraps up bone growth, and we're going to kind of switch gears and talk about bone remodeling and repair next. So stay tuned and continue to watch my videos. All right. I'll see you in the next video. Have a good one.